So welcome back to my YouTube channel. So we were discussing the differential equations. So in last class we were started with the non-exact differential equations. So we know that for checking the exact differential equation we see whether dou m by dou y is equal to dou n by dou x or not. And we already saw that in case of exact differential equation we derived this formula, and using this you can find the solution. And now in the non-exact differential equation we know that actually we saw in the last video also that by multiplying this by an integrating factor you can convert this non-exact differential equation into an exact differential equation. So we saw that there were different cases, so out of which we covered the first case where the non-exact differential equation is of type of a homogeneous equation, and we saw that the integrating factor was in this case was mx plus ny. So if you have not seen that video, I would request you to go and check that video once. So in today's class we will discuss on the second type of non-exact differential equations, which can be expressed in the form of f1 xy into y dx plus second function of xy into x dy equal to 0. So this is the basically the representation. So you have to keep this in mind. The first, here you should get a function of xy, and here also a second function of xy, and here you should get y dx, and here you should get x dy. And integrating factor that by which you have to multiply this to convert this non-exact differential equation into an exact differential equation is 1 divided by mx minus ny. Mx minus ny. So okay, so now let's try to understand this better with an example. So if you see this question, so always we first check whether this is an exact differential equation or not. So this is our m, this is our n. So for checking this dou m by dou y we will find out. So dou m by dou y will become m is your y plus x y square. So you will get 1 plus x into 2y, because here x is constant because we are partially differentiating with respect to y. So similarly finding out dou n by dou x. So dou x n is x minus x square y. So here you can see you will get 1 minus 2x into y. So you can clearly see that here dou m by dou y is not equal to dou n by dou x. So it is a non-exact differential equation. So what we will do is we will find the integrating factor. Okay, so we will find the integrating factor and we will multiply with this non-exact differential equation, and we will find the exact differential equation. So we know that integrating factor is mx minus ny. So when you write m is y plus x y square into x minus n is x minus x square y into y. So further simplifying it, you will get xy plus x square y square minus xy plus x square y square. So here you can clearly see that this minus xy and this plus xy will get cancelled out, and you will finally get a minus 1 by 2 x square y square as integrating factor. Now you have to multiply this integrating factor with this differential equation, non-exact differential equation, and we will get our exact differential equation. So our parent equation was xy plus xy square into dx plus x minus x square y into dy equal to 0. So here we will multiply by 1 by 2 x square y square. So 2 will get cancelled because it will go on the other side and it will become 0. So dividing by x square y square, you will get here x square y plus 1 by x dx plus, again here you will get 1 by x y square minus 1 by y dy is equal to 0. So now this is your exact differential form. So what we will do now, we will implement our formula. So our formula was we integrate m dx assuming y as constant plus, then we take the n terms without x and we integrate with respect to y dy, and we add a constant. So implementing this formula, we will get 1 by x square y plus 1 by x dx, and here our y is constant, plus here we will exclude this x term, so we will get only 1 minus 1 by y and dy plus c. So finally we will integrate this and get our final answer. So 1 by y will get outside because it is a constant, and x square, x to the power minus 2, when you will integrate it you will get x minus 2 plus 1 by minus 2 plus 1. Similarly, now adding the second, you will get 1 by x integration with respect to dx as ln x. Now coming here you will get minus ln y plus c equal to 0. So finally rearranging it and writing it, so minus this x will come down and it will give you minus 1 by xy plus ln x minus ln y plus c equal to 0. So this is your final answer. Now you can try to solve this question, and this is a homework. So you can try to solve this question by yourself, and you can see here this is a of the form of f1 xy into y dx plus here again f2 xy into x dy equal to 0. So you can simply find the integrating factor as 1 by mx minus ny, and you can multiply this integrating factor with into this non-exact differential equation, and you can get the exact differential equation, and finally you can get the answer. And if you want me to do the solution, put the solution of this equation, then you can comment and ask for it. So I hope that you have enjoyed this session. So thank you.